Summary of USGS low-level flights to map geology in Michigan and Wisconsin. The U.S. Geological Survey (USGS) in partnership with the Michigan Geological Survey, Wisconsin Geological and Natural History Survey, and other state geological surveys has initiated an ambitious project involving low-level airplane flights to map the subsurface geology of Michigan's Upper Peninsula and northern Wisconsin. This effort, detailed in an article from Upper Michigan's source June 28, 2025, is part of the USGS Earth Mapping Resources Initiative (EarthMRI), a nationwide program aimed at modernizing geological data to identify and secure critical mineral resources vital to the United States economy and national security. For geologists and earth science enthusiasts, this project offers a wealth of new data and insights into the geological framework of a mineral-rich region, with implications for resource exploration, environmental management, and scientific research. Project overview and objectives. The primary objective of the low-level flight program is to create detailed, high-resolution maps of the subsurface geology in Michigan's Upper Peninsula and northern Wisconsin, excluding Menominee County in Michigan. The region is geologically significant due to its location within the Pennaky in Oregon and the Mid-Continent Rift System, both of which are known for hosting critical mineral deposits. These minerals, including those found in mafic magmatic systems, volcanogenic seafloor systems, porphyry systems, and even mine tailings, are essential for industries such as renewable energy, electronics, and defense. The USGS EarthMRI program, launched under the authority of the Energy Act of 2020, seeks to identify and assess the availability of 50 critical minerals with vulnerable supply chains, addressing both economic and national security concerns. The project employs airborne geophysical technology, specifically airborne electromagnetic EM surveys, to collect data that will produce three-dimensional 3D representations of the subsurface. These surveys are designed to map geological structures and mineral deposits from the surface down to depths of approximately 1,500 feet 500 meters. The resulting data will provide geologists with a clearer understanding of the region's complex tectonic history, mineral resource potential, and hydrogeological characteristics, which are critical for sustainable resource management and environmental planning. Methodology and technology. The methodology involves fixed-wing aircraft flying at low altitudes, approximately 300 feet 100 meters above the ground, in a systematic grid pattern. This low-altitude approach ensures high-resolution data collection, allowing for precise mapping of subsurface features. The aircraft are equipped with advanced geophysical instruments that measure the electrical resistivity of the subsurface using AEM techniques. Variations in resistivity can indicate different rock types, mineral deposits, and geological structures, enabling scientists to construct detailed 3D models of the subsurface. The AEM data is particularly valuable because it can penetrate deep into the Earth, providing insights into geological features that are not visible at the surface. For example, the data can reveal the presence of conductive mineral deposits, fault zones, or groundwater aquifers. These models are essential for understanding the distribution of critical minerals, such as copper, nickel, cobalt, and rare earth elements, which are often associated with the mafic and volcanogenic systems prevalent in the region. Additionally, the surveys will examine mine tailings, which may contain recoverable minerals, offering opportunities for sustainable resource extraction. The flights are conducted by highly trained pilots who adhere to strict Federal Aviation Administration (FAA) regulations to ensure safety. The grid pattern ensures comprehensive coverage of the survey area, maximizing the amount of data collected. The project also involves collaboration with private companies, academic institutions, and other government agencies, which enhances the technical expertise and resources available for data interpretation and application. Timeline and operations. The data collection phase began in late May or early June 2025 and is expected to continue through late fall 2025. However, if weather conditions, such as heavy snow or high winds, disrupt the flight schedule, the project may extend into spring or summer 2026. The flights are conducted during daylight hours to ensure optimal visibility and safety, with aircraft operating at low altitudes over rural and urban areas alike. The USGS and its partners have taken steps to minimize disturbances to local communities, such as avoiding restricted airspace and coordinating with local authorities. The extended timeline reflects the complexity and scale of the project, as well as the need for favorable weather conditions to ensure data quality. The Upper Peninsula and northern Wisconsin experience harsh winters, which can limit flight operations, so the project is designed with flexibility to accommodate these challenges. The continuation into 2026, if necessary, will ensure that the survey covers the entire target area comprehensively. Scientific and practical significance for geologists and earth science enthusiasts. The data generated by this project is of immense scientific value. The high-resolution 3D models will improve understanding of the geological evolution of the Pennakean Oregon and Mid-Continent Rift System to ancient geological features that have shaped the region's mineral wealth. The Pennakean Oregon, formed approximately 1.8 billion years ago during a major tectonic event, is associated with volcanogenic massive sulfide deposits, while the Mid-Continent Rift System, dating back about 1.1 billion years, is known for its copper and nickel deposits. By mapping these systems in detail, the project will provide critical insights into their formation and mineralization processes. The data will also support a wide range of applications beyond mineral exploration. For example, it will aid in regional geologic mapping, which is essential for understanding the broader tectonic framework of the region. It will also contribute to water resource studies by identifying aquifers and groundwater flow paths, which are critical for managing water supplies in the Upper Peninsula and northern Wisconsin. Additionally, the survey will enhance surficial mapping efforts, helping to characterize soil and sediment layers that influence land use and environmental planning. Sarah Pearson, director of the Michigan Geological Survey, emphasized the importance of this data, stating that it is incredibly valuable for sustainable land and resource management, as well as public health protection. The information will help policymakers and scientists make informed decisions about resource extraction, environmental conservation, and infrastructure development. For example, identifying the location of critical minerals can reduce the environmental impact of mining by targeting areas with high resource potential, while mapping groundwater resources can support efforts to protect drinking water supplies, broader context and implications. This project is part of a broader national effort under the USGS MRI program to modernize the United States geological data and secure its critical mineral supply chains. The Energy Act of 2020 highlighted the strategic importance of critical minerals, many of which are imported and subject to supply chain vulnerabilities. By conducting detailed geophysical surveys across the country, the USGS aims to reduce reliance on foreign minerals and support domestic industries. The collaboration between federal, state, and private entities underscores the interdisciplinary nature of the project. Academic researchers will use the data to advance studies in mineralogy, tectonics, and geophysics, while private companies may leverage it to identify new exploration targets. The involvement of multiple state geological surveys ensures that the data is tailored to regional needs, enhancing its utility for local stakeholders. For earth science enthusiasts, the project also offers an opportunity to engage with cutting-edge geophysical technology and its applications. The AEM surveys represent a state-of-the-art approach to geological mapping, combining advanced instrumentation with computational modeling to produce unprecedented insights into the Earth's subsurface. The resulting datasets will be publicly available through the USGS, providing a valuable resource for researchers, educators, and students. Conclusion: the USGS Low-Level Flight Program in Michigan's Upper Peninsula and northern Wisconsin is a landmark effort to map the region's geology using advanced airborne geophysical technology. By collecting high-resolution AEM data, the project will produce detailed 3D models of the subsurface, revealing critical mineral deposits, geological structures, and groundwater resources. This information will support mineral exploration, environmental management, and scientific research, while contributing to national efforts to secure critical mineral supply chains. For geologists and earth science enthusiasts, the project offers a unique opportunity to explore the geological history and resource potential of a mineral-rich region, with far-reaching implications for science and society.